Hello class, so this is color lecture part 2. Alright, we're first going to talk about 3 uses of color: local, optical, and arbitrary. Okay, so local color refers to the color of the object under ordinary daylight. So under ordinary daylight, grass is green, oranges are orange, ripe tomatoes are red. You can also think of local color as the color that you would associate with the object, or the color that's intrinsic to the object. So on this work on the bottom, Andy Warhol uses the local colors of these objects. So he uses local color of grass, uses local color of these flowers. Optical color refers to the colors of an object under lighting other than ordinary daylight. So although grass is green under ordinary daylight, and that's the color that we associate with grass, to our eye, grass can also be blue-green, yellow-green, gray-green, depending on the lighting. Okay, so in the morning, grass might be, a yellow-green. Towards nighttime, it may be a blue-green. On a cloudy day, it might be a gray-green. Okay, and you can see here in the shadow, this grass is a little bit bluer, and in the sunlight, it's a little yellower. Arbitrary color refers to the subjective use of color, and this is for aesthetic or emotional purposes. So basically, the artist disregards the color that could be seen with the eye under any lighting condition, and they choose another color, and they do this for expressive effect. So here, Andy Warhol makes the grass red. Okay, grass is never red. Okay, and this is referring to representational painting. Okay, since it refers to a recognizable subject matter, but not all painting refers to a recognizable subject matter, because arbitrary implies randomness, and an artist uses colors deliberate. Okay, so artists aren't choosing color at random. Choosing a color at random would be like closing your eyes, going into one's paint box, and just grabbing a color. But artists don't do that. They choose colors intentionally. So here we have this girl, and she is green. Her face is green. Consider for a moment, what effect do you think that has by making her face green? Perhaps it makes her look ill or sick. What do you think? Now let's talk about warm and cool colors. Okay, some colors refer to as warm, and some colors refer to as cool. In this case, which one would you say is a warm color? Probably this one. Which one would you say is a cool color? Probably this one. And why do you think that? Perhaps it's because things that we associate with coolness, are this color, and things that we associate with warmness happen to be this color. Okay, now not officially, but usually, we refer to warm colors as red, violet to yellow on the color wheel. We refer to cool colors as violet to yellow-green. And think of what things that are warm that are these colors: fire, molten lava, the sun. And what things are these colors? Night, ice, the ocean. Well, ice is actually clear, but the ocean is blue, or blue-green. So although we refer to some colors as warm and some colors as cool, how cool or warm a color appears depends on the colors around it. So in this case, these are all cool colors except for maybe the face. But we can see that this color is warmer than this. Okay, and the dress is cooler than the wall. Now, warm and cool colors is an important concept to understand atmospheric perspective. An atmospheric perspective is what happens to an object's color as it recedes in space. And now this is not just talking about space as in across the room, but this is in space in terms of hundreds of feet. Okay, and something happens to an object's color, its hue, value, and saturation. And saturation and intensity are the same thing. As it moves from A to B. And just looking at this for a moment, look at the trees. What happens to its color when it goes from A to B? Okay, what generally happens is that the hue moves towards blue, okay, it becomes cooler, the value lightens, and the value contrast, which is a difference in value within the object, decreases, and the saturation lowers, so it becomes duller. And so let's back at this. So the hue becomes cooler, so you see how it goes from a green to a bluish green, it goes closer to blue. The value lightens, so overall it's getting lighter from A to B to perhaps imaginary C over here. The value contrast decreases. You can see the difference between the darks and the lights here. It's not so much the farther it goes back. And the saturation lowers. Okay? The color becomes duller, comes closer to gray. And you can see it's brighter up here, and a little bit duller the farther away it goes back. Now it doesn't always go to blue. In some cases, under some atmospheric conditions, it could go to red, but usually it does go to blue. And you can look at this one. See as it goes back, the objects are getting cooler overall. There's less contrast back here, and it's lighter. You see the same thing here. It's cooler as it goes back, and a bit lighter. So because we've experienced atmospheric perspective so often, even in abstract designs, we think that cool colors recede. Okay, so if you look at these two forms, there's two shapes, it looks like the red one's coming forward. Because it doesn't have a recognizable subject matter, but as you can see, the red form comes forward and the blue form goes back. Okay, but not all artists are interested in creating depth. Some are trying to flatten space. And in this case, the artist could place things in the front that are cool and things in the back that are warm, and so flatten it out. And that's what David Hockney does in this design. Or something in the back that's warm, and it comes forward. Something in the front that's cool, and it pushes back. It helps to flatten all this out.